Hi everyone, Elliot Jacobson here for Advanced Advantage Play. And today I want to talk about a side bet that I've actually written an article about, and it's on my blog. But I got a question today in the email that made it seem like maybe that should get a bit of an update. So let's just go straight to that question. And here it is. All right, the question is, and this is, by the way, this is the type of email that I really like to get. All right, this is no BS here, right? It's polite, it's on topic. Let's go right to the part of it that kind of matters. He says, I had two Baccarat side bet queries I hope you might be able to assist me with as follows. The first one is the Big Tiger Baccarat side bet. And he says, your website includes a July 2024 analysis of the side bet with 50 to 1 odds and correctly concludes that it is fairly unhelpful to the aspiring advantage player. I assume this payout is based on and he named a casino, so I crossed it out, version. Now he says casinos in another country offer this side bet with an increased 55 to 1 payout. My calculation puts that house edge at a much lower 6.94%. Good job doing the house edge, my friend. Which theoretically should make this a much more attractive advantage play proposition if card counted with an appropriate system. On the basis that it doesn't require significant effort on your part, it would be greatly appreciated if you were to provide a summary of how the improved payout odds would change the card counting system and simulation outcomes outlined for the 50 to 1 version in your article. So let me first just sort of show you the article he is referring to. So hang on a second. Here it is. So if you go to my website, advancedadvantageplay.com, you scroll down, you will find an article card counting the Big Tiger side bet. And this is the article that he's referring to, and it shows the card counting system and my conclusions about this wager right here. So, okay, let's actually answer this question. First thing I want to do is just show you the 50 to 1 version, just so you have that as a baseline. So I think that's about as large as I can make it right there. And we see this has a house edge, and that's this under this P times EV. The house edge with the negative sign is 15.2533%. All right, so what do we do with that? Well, I ran my simulation of 100 million shoes, and when I did that simulation with a cut card at 14, I had a target true count of +8. And the bottom line here is this units won per 100 hands being 0.256. And that's just not a very good win rate. That's essentially saying if you're betting $100, then every 100 hands, your profit will be about $25.60. So that's 100 hands observed, right? You're not necessarily playing all those hands. So that's, you observe 100 hands, you'll play some, you won't play some others. How often will you be playing? About 3.54% of the hands will have a true count of 8 or higher. So kind of a pathetic situation. So what he asked about was the 55 to 1 payout. So here, let me make this a little bit larger. And you can see here the house edge is down to 6.9448%. You can see this right here under the P times EV. So that is a dramatically lower house edge than for the previous version of 15+%. So yeah, he's right. There's a good chance this thing is beatable. And when I ran the simulation on this, what I got now was a units won per 100 hands of 1.017. All right, I'm getting over a unit per 100 hands. So that's about 4 times as good as the 50 to 1 wager. And that definitely puts this in the playable side as far as your win rate. Now, the problem is that, oh, and by the way, you're playing quite a few more hands. You're playing 15.28% of the hands, right? Your target true count is now only +3. So you're going to be playing a lot more of the hands. Your edge is going to be over 6%. When you make this bet on average, you will have more than a 6% edge on the house. But the problem is, this is one of those wagers that's just not going to hit very often. So if it pays 55 to 1, it means you may be losing 48, 49, 50 wagers on average for every one you win. And that's on average. You might go 100 or 150 bets without winning this thing. So this is one of those very high variance side bets. And that's why the desirability index is way down there at 3.64. But at any rate, what I wanted to show you on this thing that is a little bit behind the scenes is I wanted to take you over to my computer program part of this thing and show you how that works. So here we have the computer program I've written, and I get a lot of comments from people who say, well, I wrote this program and I simulated 1 million shoes and it took a week. I'm only assuming they're writing it in some scripting language. I know Python is very, very slow like that. So I just want to show you how fast this program runs, just so you can see it. So first of all, let's go over to the part of this that is the combinatorial analysis. And let me show you how long that takes to run. So I will just run a.exe. And you see that it computes the house edge in about, what was that? Half a second, 1 second. And you can see that it's spitting out the number of hands that are winning hands for this thing. That's that top number, the number of losing hands, and then the house edge. So now let me actually take you back to the simulation of the count system to show you how that thing is going to look. I'm just going to run Big Tiger, and I have a cut card fixed in this code at 14 cards. So here we go, Big Tiger. It's going to ask the number of shoes. So let's run 20 million shoes, all right? 1, 2, 3, 4, 5, 6. Here we go, 20 million shoes. And what you see it doing right now is it's printing out a log as it simulates each of those shoes. And it's telling me the running house edge. That's just kind of a way for me to judge whether there might be some error in this code that's going to mean that it's not working right. So I do the running house edge and a count of the number of shoes. So, okay, I don't know what else to say. I'm going to have to just improvise for a few more shoes here. But, this is how long it should take your code. If you're writing simulation code, this is the speed it should run at. You should roughly be getting 1 million shoes within 5 seconds, at most 10 seconds, not a week for 1 million shoes. Okay, what did it spit out right here? Well, what it printed out was along the left-hand column, here is a true count. So 0, 1, 2, and so on. It's telling you the true count. It's telling you the number of hands that occurred at that true count. Now, 0 is a catch-all, right? So anything that's 0 or less just gets recorded as 0. So we see that on, this is how many hands were at the 0 or less true count. Likewise, at the bottom, I have a catch-all on the top end, a 48 or a higher true count. This is the total number of hands that occurred there. Now, the next number that it spits out is the expected value or the house edge whenever the true count is that thing. So when the true count is 0 or lower, then on average, there is a 10.9% house edge. Whenever the true count is, for example, here we have 2. When the true count is 2, you see there's about a 1.6% house edge. But what we see here is when the true count is 3 or higher, those negative numbers are now positive numbers. And we can actually see how the house edge is increasing as the count goes up. So the next step that I do is to simply import that into an Excel computer program. I just import that CSV comma separated values that are in that data, and I import that directly into Excel. And then I can do my Excel computations, and I'm not going to go through those computations, but that is how I come up with these numbers right here. So that's a little bit of behind the scenes that I wanted to share with you as far as this goes. I mean, the main reason is that I just wanted you to see how fast these programs run, so that if you're somebody out there who is writing code, you know you have to use a language that will sort of do this at that speed if you really want to have any hope of generating statistically significant results. So, okay, everybody, I hope that was fun for you. I certainly think that giving them behind the scenes like this is eye-opening. And the big tiger is now roaring. I guess it's a pretty small roar, but let's count it as a roar. All right, everyone, Sally Jacobson. See you later.